So not only do we have a homeostatic mechanisms to increase water intake, we also have mechanisms that regulate the water output. And so from the discussion in the urinary system, you might remember that there is a hormone called ADH. So this is my anti-diuretic hormone. ADH actually functions to increase water reabsorption in the kidney. So it is produced by, this ADH is produced by the hypothalamus. The hypothalamus also produces this, and then it is stored in the posterior pituitary. So it's stored in posterior pituitary, which is right next to the hypothalamus. So let's say that we have an increase in the osmolality of the ECF. What's going to happen when we do this, if we increase the osmolality, then ADH is going to be released. So ADH is released. So that's the response. Then the response of that is increasing water reabsorption, which is going to decrease the osmolality. And so this is also a negative feedback mechanism. Now, we also have a problem when we lose water really quickly because it can influence our blood pressure. And so you could also get ADH being released if there is a dramatic drop in blood pressure. So a dramatic drop in blood pressure also causes a release of ADH. So why might we have this? Say, for example, we are injured. So we have excessive amounts of bleeding. So excessive bleeding. We also have vomiting, which can really mess up your balance of water and electrolytes. And then diarrhea. And your textbook also says, there's 2 R's in diarrhea. Your textbook also says prolonged fever. So ADH can also be regulated by these mechanisms, as well as just simply detecting the solute concentration in your extracellular fluid.